Decoded.
Welcome along to Book Decoded. Today, we're diving into something really, well, mind-bending, actually. It's inspired by Michio Kaku's book, Quantum Supremacy.
Yeah.
And forget just faster computers, we're talking a whole new type of computer, one that apparently can crack problems our current digital computers, well, they just can't. Not even if they had forever. You know, with Moore's Law kind of slowing down, it really does feel like maybe the Silicon Age is winding down and the quantum age is starting.
Oh, it's absolutely a huge shift.
Yeah.
Think about it like this. A normal computer.
Like the one I'm using now.
Exactly.
Yeah.
It tackles problems step by step. You know, like a mouse in a maze, checking one path then another.
I guess sequentially?
Precisely. But a quantum computer, it's different. It can look at all the paths, well, almost instantaneously.
How?
Because it uses qubits. And a qubit, well, it isn't just 0 or 1, and this is the key part, both at the same time. That's superposition. And they can be entangled too, which means their fates are linked. They work together across just vast numbers of possibilities super fast.
Okay, that idea. Exploring all paths simultaneously. That sounds incredible. So practically, what does this mean for us? What kind of, real-world stuff does this quantum leap unlock?
Oh, the implications are massive for science, for commerce, everything, really. Imagine having virtual laboratories.
Okay.
Where these quantum computers can simulate chemical reactions right down at the atomic level.
So no more endless test tubes.
Well, maybe not no more, but it could drastically cut down the time, the cost. Think about developing new drugs.
Right.
Like for Alzheimer's. That involves these really complex misfolded protein, prions.
Yes.
Classical computers really struggle to model those accurately, but quantum computers, they could potentially simulate them, speed up finding treatments, maybe even help understand the immune system better to fight cancer.
That's huge for medicine. What else?
Energy storage, that's a big one.
Batteries, you mean, for solar and wind.
Exactly, that's the bottleneck for renewables, right? Battery capacity. The chemistry inside is just too complex for today's computers to simulate well enough. Quantum computers could simulate those reactions, help us design, like, super batteries. That could seriously speed up the shift to, a carbon-free world.
Wow, super batteries.
And it gets even more fundamental, understanding life itself. Quantum effects are key in photosynthesis, how plants are so efficient at capturing light.
Nearly 100%, isn't it?
Almost. Understanding that could lead to things like artificial leaves, maybe, recycling CO2 back into fuel.
Okay, that's amazing. So it tackles these big practical challenges, disease, energy, even understanding life. But you mentioned entanglement, superposition, these sort of bizarre quantum properties. Does this tech also push us closer to understanding reality itself?
Absolutely. Because quantum computing is quantum mechanics in action. And quantum mechanics is, well, it's weird.
Weird how?
Well, that qubit being 0 and 1 at once, that's just scratching the surface. You get particles acting like waves and particles being in multiple places simultaneously. It's the twilight zone of physics, really.
Right, like Schrodinger's cat, the alive and dead cat.
Exactly. That's a thought experiment, obviously, but it captures that core idea. A quantum system holding multiple possibilities until you kind of, look at it.
So how does that relate to computing?
It leads to ideas like the many worlds interpretation, the idea that maybe every possible outcome of a quantum event actually happens, just in its own parallel reality.
Whoa, parallel universes.
Sort of. Think of it like radio waves. There are hundreds of stations broadcasting in this room right now, right? But your radio is only tuned to one.
Okay.
A quantum computer, in a way, can kind of listen to all those possibilities, all those potential realities at once to find the best solution.
Okay, my head hurts a little now. So these machines solve real problems and give us a peek into these deep philosophical questions about reality. So for us listening, what kind of future does this all point towards?
It points towards a future where we can tackle problems we used to think were just unsolvable, truly unsolvable.
Like what?
Things like accurately predicting massive solar flares. Like the Carrington event back in 1859 that knocked out telegraphs.
Yeah, I've heard of that.
Or maybe tracking asteroids way out there that pose a threat. Stuff that needs way more processing power than classical computers will ever have.
So planetary defense, essentially.
Could be part of it. And then there are the really big questions in physics. Dark matter, dark energy.
Yeah.
What is that stuff?
Hmm.
String theory?
The really fundamental mysteries.
Exactly. Quantum computers might be the key to unlocking those secrets of creation. Maybe they'll even help us figure out if the whole universe is fundamentally just one giant quantum computer itself.
Wow. So from new medicines and super batteries to protecting Earth and maybe understanding the cosmos,
Yeah.
the potential here is just enormous.
It really is. And if these quantum computers can help us solve the deepest mysteries of the universe, maybe even crack the secret of creation itself. Do you think we might just find the ultimate answer is 42?